Alrighty, more dominoes. Minimum domino rotations for equal row. In a row of dominoes, domino, so that the tops and the bottoms swap. Okay. Return the minimum number of rotations such so that all the values in the tops are the same, or all the values in the bottoms are the same. All the values are the same. If it cannot be done, return -1. How interesting. The minimum number of rotations. What? What is going on? This seems too simple. Okay. Why? Why? I mean, okay. It seems like you just would make sure one that there's um that every that the count, the most frequent count, is equal to the number of dominoes, so that it's possible. Okay. Turn the minimum number of rotations so that all the values tops are the same. Okay, this is just weird. Okay, I think it's just something where you have your frequency 1, say frequency top is the counter of the numbers at the tops, and then the frequency bottom is the counter for the number of bottom, and you need to have something that you need to have the most frequent one be the same. The sum of the frequency for each. Okay, so if, say, for each value in, so the dominoes is from 1 to 6. So for every value in range 1 to 6, if um, say the number of times it occurs in top, which should be let's say frequency 1 is 0, is frequency top of this value if value is in frequency top, otherwise it's 0. Frequency bot, no, f2 is frequency bot of the value if the value is in frequency bot, this is 0. If f1 plus f2 is equal to n, where n is the length of the number of dominoes, then you return the minimum of f1 and f2, because let's say there was 10 dominoes and you're dealing with one, right? One maybe occurs once on top and 9 times on bottom. So the lower the 2 is the number of times you need to flip, because you just need to flip that 1 to the bottom. And I think that's, otherwise return -1. Frequency bottoms. Okay, guess I somehow screwed up. So 2. Let me go ahead and print the value f1, f2. Make sure we're on the same page. So 1 occurs once on top, 0 on bottom. 2 occurs 4 times on top and 3 times on bottom. 1, 2, 3, 4. 1, 2, 3. Oh, there can be duplicates. That could be the same on both top and bottom. I see now. Can't use frequency because of that. Can't use frequency because of that. So how many dominoes do I have to look at before I can determine what is the value to try for? I think I just need to have if I have 2 dominoes, they could be the same domino, so I don't know which value to use. If I have 2 non-identical dominoes, then I should be able to determine the key flipping one. Alright, there should be some other fairly So what's going on here? How do I know to use 2 if I don't use some frequency calculation? Can I not use some frequency calculation? Doesn't it have to be something where the most frequent domino of either the top or bottom is the one that I need to convert? Is it possible for it to be a domino, a value that's not the most frequent of either the top or the bottom? I think it has to be. Although if there's a tie, then that kind of complicates things. There's a tie. So the thing that I need either is the most frequent in the top, most frequent in the bottom, or most frequent in the top, most frequent in the bottom. I mean, I could. This should be okay. If there's a tie, there's a tie for the most frequent in the top and most frequent in the bottom. Then okay. Let's do a candidate. Possible is a list, and then I guess I can do a pass. I can do just 6 passes. Yeah, I guess I could do 6 passes. Alright. let's just do the brute force here. For every value in range 1 to 7, if, see, if the value, okay, let's say the answer is -1. Let's say the count for every value, and so the count of the flip count is 0 if so the answer is actually float infinity. And then for every index in the range of n, this is not very efficient. If tops at this index not equal to this value, or bottom of this index not equal to this value, then break. Not possible is true. Say flips is equal to float infinity. And break. Otherwise, I guess I can just, so I'm guaranteeing that either the top or the bottom has it. And I'll say the so if tops at this index equals value not equal to this the top plus equals 1, if bottoms of this index not equal to this value, the bottom plus equals 1, I think, okay. Flip top, flip bottom is zeros, and here I'll just say both are infinity. Man, this logic should be so much simpler. And then the answer is equal to the minimum of the number of times you need to flip. Flip answer, flip bottom, flip top, and then return the answer. If the answer equals float infinity, return -1, else return the answer. Okay, not quite working. So answer should be 2 here. So it goes 2 for every index in the range. Okay, let me go ahead and print out what the value for the top and the bottom is for each loop. Interesting. Why does it hit? Oh, it should be and. If it doesn't equal that value on either the top and the bottom. Okay. Okay. So could be better for sure. Hard coding 7 loops is not ideal. So how would I approach this? Because I see the first domino, it's 2 or 5. So I know that my values are either 2 or 5. Values are either 2 or 5. Can't be anything else. It has to be a value. Number of times it appears on top plus the number of times it appears on bottom. Has to be at least. Has to be at least n. And how many things could possibly satisfy that? That many, right? The number of things that appears on top, the number of things that appears on bottom. Guess I don't need the frequency tops and frequency bottom here. I don't need this possible thing either. I don't know if that makes any difference. Guess it did make a difference. 95%. Do I need to know the frequencies? Would it make it any faster? Okay. Okay, just I'm gonna try to code something that makes sense. So what was my original thing that just didn't work? Guess I don't have any more. So the frequency has to be at least n, right? Okay, let me try the frequency stuff again. For every value in range 1 to 7, if the f1 is 0 if the value is not in frequency top, else it's frequency top of this value. 0 value not in frequency bot, else it's frequency bot for this value. And if f1 plus f2 is less than n, then continue. Answer is 0. I think there's has to be at least that. Okay. So n is the length of the number of dominoes, and then for every index in range n, if no, I need to do the counter stuff now. So flip top, flip bottom is 0, 0 again. So for every index, if the values are not the same, index not equal to value, and bottom's index not equal to value, and then this is flip top, flip bottom is going to be infinities. And break. Otherwise, if the top is not this value, then you need to flip the top. If bottoms is not this value, then you need to flip the bottom. And after loop, you say answer equals min of answer, flip top or flip bottom. And then if the answer is infinity, I guess I can maybe use n rather than infinities. Whatever, for infinity. If answer is infinity, turn -1, turn answer. Okay, I don't know. Maybe the counter stuff, it doesn't really. It shortcuts it a little bit. Yeah. Because you do the counter, which is a pass through anyways. Versus. And the counter is just for this one semi-shortcut if it's not possible. Okay. Alright, I guess it is what it is. It's kind of very much hard-coded. At some point maybe the counter does go faster. There should be some other logic that I can do here. There has to be some other logic that I can do here that makes this faster. But apparently this is pretty darn fast compared to other solutions. Hard-coded solution, kind of. Every value in range. I guess the thing here is, even though it seems kind of slow, this exits the loop pretty darn fast, because once it detects like here, right? If you do 2, 5 as your first domino, even though you're trying all possible values of dominoes from 1 through 6, on the very first domino, on the very first if statement, it'll find that it's not possible to do 1, and then it'll stop. And then it'll do a 2 all the way to the end, and it won't even do. It'll do a 2 all the way to the end. Once it ends, you know what? I think I can do something where let's say answers answers this. We can say if flip top not equal to float infinity, then I think I can just break. Because if it does anything correct, I think it should. Does anything correct, I think it should be the answer. Return. Actually, if it's not infinity, then I can just say return the minimum of flip top and flip bottom. And then return -1 here. I don't know if this is sound logic, actually. Maybe it is. Whoa, it's slower considerably. What is going on? Why is that slower? How in the world is that slower? What? Because you don't do the minimum? You're not comparing to infinities? What? Yeah, it's slower. What? So how is this faster? Answer equals the minimum. Answer flip bottom, flip top. And then do another loop even though you know that it doesn't need it. Answer equals float. Whoa. I wonder if this is any faster if I use n rather than float infinity. Break. Answer not equal float infinity. What if I did something if flip bottom? No, that's not right. I was gonna do like an equality comparison between flip bottom and flip top, but it doesn't really matter. Or there could be a case where the flip bottom and flip top is the same, and that's the answer. If all right, what do I want to do here? All right, I think this is probably turn -1 if answer equals flip infinity. Else return answer. Okay, I think that's how it works. And I am done trying to optimize this shit. Okay, summary. This is actually try every possible domino value to see what the minimum flips would be to obtain each domino to have that as its top or bottom. So this is actually trying every possibility, but this is the key thing, needs to recognize when it's not possible, basically short circuit evaluation, short circuit logic, and stop iterating on the first domino where the value does not appear on that piece. So even though it's trying every single value, it's going to stop immediately once it sees that the values doesn't appear on either the top or bottom at that index. Obviously, you use a nested for loop where outer loop goes through all values and inner loop goes through all indices, counting flips at each index. Note here that the logic also works even if there's a piece where the values in both the top and the bottom. So it's not like the top appears, so you have to flip to the bottom, because the bottom could also be the same value. So only if the top isn't of that value, then you flip to the top, and then only if the bottom isn't of that value, you flip to the bottom. So just be careful with that. Time complexity, this is O of n. It's kind of like O of n. It's kind of O of n times O of k, where k is the values in dominoes, and n is number of dominoes. Where k is the values in dominoes. It's not quite right. Well, it's O of n where n is number of dominoes, with some maybe minor factor related to how long it takes to short circuit evaluate, short circuit, reject certain values as a possibility. Like in theory, if you had something where all the dominoes had like let's say a 2 on top and a 4 on bottom, it would actually do it twice, right? It would go through. It wouldn't short circuit anything because twos would all be there and fours would all be there. So it's not quite O of n because in theory the dominoes could have maybe more values on them, and then it takes longer to falsify, whatever. But it's roughly O of n. Space complexity, this is O of 1 since we're just using constant variables and no arrays, I don't think.